It is 2 hours UTC, and here we are again, Astronomy Daily Live. Hey, everybody, you can call me Cosmic, and welcome once again to this daily live stream where we all come together every single day, gather in a virtual circle. I sort of imagine a nice circle of friends sitting out on the back porch with our favorite beverage or other consumable and just sitting back, enjoying the time and talking about astronomy for a while, just for a little while. Every single day, get together, few friends, maybe eventually a couple of dozen or so. At the moment, it's just a few, and that is okie dokie. So yeah, hey, hope everybody's doing well. Hope your day and or evening is going well. I'm just gonna get myself started here. Like to monitor the live stream on my smartphone over here, and I like to monitor the chat over on my Linux machine over here, while this poor, suffering Windows machine, Windows 7 machine, uh, cranks away at the video and the audio. So yeah, hope everybody's doing well. Hey there, Bob Dog. How's everything going up there? Hope everything's well. Haven't seen you in a while, so glad you could drop in. Changed format a little tiny bit, just doing an experiment. You know, always trying to get better, um, and so I've sort of shortened these a little bit. I try to go between like half an hour and 45 minutes now or so. Just an experiment to see how I like it. If it draws maybe a different crowd, a bigger crowd. Always like to have the regulars in though. So hey there, Tom. Nice to see you in the chat again. Hope everything's well. Everything's good here. I was up late last night outside. Had clear conditions, but it was windy. So not really any serious observing going on. Trying still to characterize this telescope system, seeing if I can do some kind of guiding, either manual guiding or auto guiding. Let me straighten this out a little bit. It's gonna drive me insane if things aren't a little bit more straight. So um, yeah, it's so very preliminary results with some data that I took on the evening of March 15th, where I know that the seeing wasn't all that great. I'm getting um, astrometry around 3/4 of an arc second or so, which is really great. I've got pixels that are about 1 arc second, so being able to measure things with an accuracy of less than a pixel, yeah, I'm okay with that. I'm good. I think the seeing definitely played a role there as well. And as far as the photometry goes, it looks like that evening accuracy was around between 1/4 and 1/3 of a magnitude or so, plus or minus about 1/4 um, magnitude. So I think given the conditions, um, and also the fact that because of me not being able to guide, I'm having to keep the exposures relatively short, like 2 seconds, 3 seconds max. And with bad seeing, um, um, uh, um, what you'll see is scintillation, which is just twinkling, right? And so if the twinkling is bad enough, or extreme enough, no judgments here, um, then a 2-second exposure, I'm gonna still be sampling scintillation, and I definitely am seeing that um, in the data. So, but between a quarter and a third of a magnitude um, um, accuracy, I'm not going to complain too much about that. If that's the worst, if that's the worst it gets, then I'm pretty good with that. So now I'm working on a different data set that I took the evening of the 29th of March, and that has um, that has its own set of challenges, which I'm just getting into now. Mainly, again, due to tracking problems. The I looked at three um, um, open clusters. I looked at M46, M37, and M67, and uh, so I've got a good sample of targets in terms of being able to measure positions and um, differential magnitudes. Uh, Problem is, and um, continues to be, the tracking. So it's just the stars go all over the place. They're just, I mean, and I'm sort of exaggerating a little bit here. They sort of go in steps, and maybe they'll scooch over, and then they'll scooch this way, and then they'll scooch over, and then they'll scooch this way, and they'll drift this way and drift up. So over the course of like 100 images or so, there's a lot of drift. This is also an alt-as mount, which means that there's field rotation as well. So so I have to come up with a way of registering, that is, shifting, rotating, and then adding. So I've got to do that, for like 100 images or whatever it is. And if the tracking is really, really bad, then it's sort of all over the place. If the tracking is good, I can cheat a little bit, and the stacking isn't all that hard. But when it's sort of jumping, uh, you know, big jumps, then I have to move to other means, which involves pattern matching. And so I've been just uh, burning my brain all day long, writing code, pattern matching code, and it's just insanity. It's just total insanity. But as you can see, as you can see, um, the smile on my face means that I'm having a good time. It's just maddening. It's just absolutely maddening. But okay, I am a mad scientist, and so uh, it's it's a blast. Anyway, last night's work was more about how learning more about how to drive this thing. It turns out that the autoguider does operate the way I think it does. It took me a little while to figure out how to turn it on and how to make it go and all that. So you know that was relatively easy. Um, and what I'm going to do in the short term, at least, and maybe in the long term, it depends on how well I can drive this sucker. but at least in the short term, maybe medium term, I want to manually guide. Now, that might cause some of you to gasp in horror, right? And it sort of makes me gasp in horror a little bit. But then I think about it. I think about it a little bit, and it's like, you know what? For almost 100 years, maybe even a little bit more, ever since photographic astronomy, you know, being able to, you know, uh, um, take long exposures at telescopes, astronomers have had to manually guide. So what I'm thinking, what I'm thinking is that if they can do it, and they did it for a long, long, long time before auto guiding came onto the playing field, right? If they can do it, I probably can too. It's just a matter of learning how to drive. So last night was sort of my first uh, driving lesson in terms of that. Now I had to contend with wind, which made the stars jiggle, right? So I'd be looking at my guide star, and it would be a nice point, and then I'd get a gust of wind, and it would turn into this faint, blurry line, right? And it's like it's pretty hard to guide on that. What uh, Steve? As far as I know, the Earth is really round. I got pretty good evidence. Pretty good evidence. So yeah, yeah, I think so. I think so. Um, so last night's task was just learning how to drive this guy, and um, getting into the concept of what's that called? Our um, uh, Getting into the concept of backlash. Backlash. So the uh, um, the gears on these scopes aren't perfect. There's always a little bit of a wobble in them, a little bit of a looseness that Celestron has sort of dealt with by putting in this anti-backlash mechanism. And for the life of me, I cannot figure it out yet. So I think I've almost got my head wrapped around it. Almost. I'm going to have to mess around with it a little bit more on the next clear night, which may not be for a little while. Don't know. Don't know yet. But I'm hoping to have an understanding of backlash settled pretty soon. As it stands now, that's what I spent most of last evening sort of struggling with. I guess that is the right term. It's not really a struggle, um, but just trying to understand what it's doing, and I, I think I've come to the conclusion that I really don't like the backlash mechanism, um, um, anti-backlash mechanism, at least for what I'm doing. I think if I was just looking with my eyes, I think it would be a different story. But I'm trying to guide, right? I'm trying to guide, and so if I'm having to, you know, move up, down, left, right, I don't think I want the anti-backlash on, because that just seems to knock the telescope way out of alignment, and so yeah, haven't quite figured that out yet. I do know that um, that you can set the telescope up to sort of to slew onto a target coming from a particular direction, and what that does is it keeps all the gears tight, at least in that direction, either like up and left, or up and right, or down, combinations of the four, right? So I can sort of choose, which way the telescope sort of slews onto a target, and then as long as I'm able to uh, uh, um, as long as I'm able to guide just moving in those two directions, then everything seems to sort of be okay. If I have to guide in either of the other two directions against the backlash, then it loosens up the worm gears and the tracking goes insane and the guiding just goes gone, right? Just gone. So, but so yeah, it's still a learning curve, and I think I'll get there. I think I'll get there eventually. So, cheers. I've got hydrogen hydroxide tonight, a nice calming chemical, one of the most amazing chemicals in the universe. So, cheers. How do I know, Steve? I don't. I don't. As a scientist, I my thing is to remain skeptical yet open-minded. So yeah, um, don't know, don't know, and yeah, but there's a lot more to astronomy than just the shapes of things. Astronomy is about how things move, what their relationships are, how they've evolved, what they're made of, temperatures, distances, whew, you name it, you name it. So shape is extremely important, of course, but it's one small piece of a much larger puzzle, and so um, uh, yeah, I mean, in terms of the shape of the Earth, seems to me that it's round, but spherical. That is. Um, Seeing some pictures, we can look out into the universe, and lots of other things are. So there's no reason to sort of doubt, at least at this point, that our situation is unique or different in any way. So, all right, I'm going to move on, and I found a few years ago. It's really amazing how time flies, but back in I'm going to yeah, July. I'm going to share my screen here. Back in 2014, it's been almost 4 years. 4 years. Uh, I was a podcaster for the 365 Days of Astronomy. That's Pamela Gay et al. Uh, run, and I was doing a podcast on the day or near the day of the um, um, Apogee, and the Apogee is the the um, place in the orbit of the moon around the Earth where it's the furthest away. So that happens about every month or so. And what I would do is I would go to archive.org and I would find an interesting, what I thought, sort of an interesting um, paper, and I would do a deep dive, you know, do a full analysis, really, really read it carefully, um, you know, look at the references, uh, do all the work, to figure out what they're talking about, and then create a podcast, produce a podcast to sort of explain, the paper and discuss it and all of that. And that was a lot of fun, and I enjoyed it thoroughly. What I noticed today was I'm gonna try to do this so it doesn't. There we go. Found a paper today that came out just today, uh, entitled "The First Naked Eye Superflare Detected from Proxima Centauri." And I don't, I don't know if this was the one that they were just talking about a couple of weeks ago, or if this is a different one. I haven't dove into the paper at all yet. But what I noticed was that this was observed with a system called the EvryScope, EVRY, EvryScope, and that set a red flag. Well, not a red flag, but sort of uh, an exciting little flare in my head, because back on July 29th, 2014, I did a podcast on the EvryScope sky survey system. And so you can still go to cosmoquest.org, and if you type in um, Apogee podcast and then search around, you'll eventually find the one that I did for July 29th, 2014, called the EvryScope Sky Survey System. And there is the transcript. So I would write these out. These are the kinds of things that I would write out, and then essentially, just read, record it, and then send the recording. I'd put some of my space music on um, in the background, and I would just, read this transcript that I had written. Excuse me. Um, and so there it is. Um, and so yeah, it's a full sky gigapixel scale telescope. Um, uh, let's see. Let's see. The goal of EvrySky survey is to image a large part of the sky as deep as possible. I guess the ultimate system would be one for example, that images the entire sky. Okay, yeah. That's so important. Let's see, I'm trying to remember the EvryScope that these guys are developing at the time. It wasn't even finished yet. Um, Takes an image of the sky every 2 minutes to a limiting magnitude of 16.5. So yeah, um, takes an image of the entire visible sky every 2 minutes. down to 16 and a half or so, with millimagnitude. I said precision. I probably meant to say accuracy there. Oh well. Um, but so what they do, instead of using just a single telescope, they've created this array of 23 of them, which are 7 centimeters in diameter. Yes, yes, you heard it right. They are 2-inch telescopes. 2-inch telescopes, and yeah, I'll bet you this is still here. Let's look at the paper. What I wanted to do, I mean, I I think that this is extremely awesome, right? That the EvryScope has observed this flare, and I definitely want to look at this paper. But what I was really excited about was to hear that the EvryScope was um, operational and actually doing something useful and interesting and scientifically valid. I think that's very, very awesome. So the first thing that I wanted to do, so many things that I want to do. It's horrible. Uncle Bill, Inner Light has joined the Discord server. Hello, Inner Light. I'm just going to type in, hello, Inner Light. And Uncle Bill is actually taking a short break. Wow, I didn't think that you took any breaks. Didn't know. I didn't know. Huh. All right, well, cool. Anyways, so check out my podcast. You can hear me as I was almost 4 years ago. I don't think I've changed very much. Just gotten a little older. That's about it. So here's the first paper I saw. As you can see, this was published on the 30th of June, 2014. And what I wanted to do was just show you a picture of the scope itself. See, so what they did is they created this dome, right? This dome that is on like an equatorial mount, right? And then they put all these telescopes on them. Isn't that cool? Now, what I really wanted to do was I wanted to go over to archive.org because I try to keep track of, whoops, hive.org. I try to keep track of articles that are um, hitting hitting the bleeding edge, but I might have missed this one. So what I want to do is go over there now and see if there are any updates on the EvryScope. Because what I was most interested in, is seeing if they were going to allow anyone access to their data. That's what I was most interested in. So here's one from 2015. Okay, that one I was aware of. I don't see anything else. I don't see anything else. Let's try Google. I don't even know if EvryScope. I don't even know if it has a website. I guess we're going to find out. EvryScope telescope system. Looks like they have a website. University of North Carolina. Yep, University of North Carolina. That's them. unc.edu. Looks like they've come a little ways. Ooh, they have a real picture. Wow. EvryScope is an array of telescopes pointed at every part of the accessible sky simultaneously and continuously, together forming a gigapixel scale telescope monitoring an overlapping 8,000 square degree field every 2 minutes. I love it. I love it. So it's been operating since May of 2015. And it looks like they're going to have another one running running soon. Very cool. Very cool. Let's take a look. Ooh, here's a project update. Here's a project update from January 9th. So that's not too long ago. It's just a couple of months ago. Let's see what they have to say here. 2 project update posters from the Know Thy Star, Know Thy Planet conference in Pasadena. Um, so a couple of posters. That's cool. That's it. Well, that's cool though. See, the years years of 2-minute cadence observation of every test target. Holy moly. Oh, that's awesome. That is so cool. And can't really see things incredibly well in terms of error bars. But yeah, they're getting down to you know, tenth of a magnitude precision here at least. Not bad. Not bad. Yeah, that's that's uh that's sort of the kind of stuff I want to be seeing for sure. For sure. Um, can't really see the numbers here, so I don't know how deep of a dip that is as far as the exoplanets go. So, but pretty cool. Pretty cool. So EvryScope north, EvryScope south. Wow. The one thing that I, as I said, the one thing that I do really want to find out here is whether this data is available. EvryScope images. We've been working hard to optimize our image quality over the last year, including building some of the first fully robotic alignment systems for dozens of camera lenses. We're routinely aligning our lenses with few micron level repeatability across the entire field. I've developed new tip tilt focus alignment method, blah, 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 blah. Pipeline, the EvryScope pipeline processes 300 gigabytes of image data to detect, measure, and insert approximately 600 million object detections each night, resulting 10, 10 tens of terabytes database is queryable rapidly enough to extract light curves for tens of thousands of targets. All right, but I want to be able to grab this stuff. How do I do that? Co-adding. Oh, come on. You gotta tell me how to get this data. Oh man. How do we get access to it though? That's not okay. Here we go. Image generate light curve, deeper observations. System hardware is working perfectly and has been for over a year. Whether snowstorms, a direct lightning strike, and a magnitude 8.5 earthquake. On this page, we've detailed the status of the next steps. But I want to know, where can I get the data? This is NSF funded. So I would think that we would have access to it. Yeah. Yeah, I'm not seeing anywhere here. I guess let's just look around a little bit. Read, okay. Okay, this is the one we already know about. Let's go to the front page, see if there's any data access. They're going to be at the Winter AAS. Huh. Results. Man, I'm not seeing anywhere in here access to the data yet, which is that's kind of a bummer. 'Cause it'd be nice to see how I mean that's a lot of data. That's a heck of a lot of data. Lurking again. Cool. All right. Well, anyway, the EvryScope I think is a very, very, very exciting um, project. It definitely, isn't the kind of, I mean, it's not um, um, LSST, which is going to see down to 22nd magnitude or anything. This can see to um, you know 16 and a half, 17 it says, and which is adequate. There's a lot of stuff. There's a lot of stuff um, there. So yeah, pretty amazing. Pretty amazing. As I said, the only thing that I don't see is data access. But what a great design. What a fantastic design. Like a mushroom. Yeah. Cool. Okay. Well, hmm. Well, check those papers out for sure. You can get a link to the paper that I talked about in my podcast from 2014 on the podcast page itself. So you can do that. It looks like there's an update, right? Uh, there was a paper that came out in 2015 that sort of updated everyone, and it looks like it's been running ever since. So that's very cool. That's very, very cool. It looks like they're in the process of building another one. I guess the EvryScope, the first one was down in Chile, and um, and I guess this new one is going to be in California. So that's pretty cool. That's pretty cool. Nice to have a southern one and a northern one if you can get away with it. And it looks like I mean, if they're in the process of building a second one, then um, then they must be having some success, right? Very cool. Very cool. Nice to see those kinds of things operational. And I guess let me look at this last one. TESS is going to be launching pretty soon. Pretty soon, a weeks, right? Long-term high cadence observations of all the test targets. So they're claiming a 5 millimagnitude per hour precision of a 10th magnitude star and 3%. I don't know what's per hour. Hmm. I'm not quite sure what that means per hour. I have to think about that a little bit. Um, but 3% at 16th magnitude, that's not too bad. That's not too bad. Cool. All right. Well, hey, I think I am going to stop sharing. I'm going to stop sharing and I'm going to, yeah, I'm already being called up to the mothership. Gonna have another draught of the good stuff here. Cheers. Extra nice tonight. Extra nice. It's a new batch. So yeah, always nice. All right, well, cool. I'm gonna get out of here for now. I appreciate you folks stopping in, joining the circle. Glad you could come by. Hi to those who are going to be watching this later. Make sure to subscribe if you haven't already. Hit the notifications, hit the thumbs up if you like this thing. You can hit the thumbs down too. I'm interested in a reaction. Interested in a reaction. So make some comments down in the comment section. I've got some links also down in the description. I'm still looking for my first panelist to come along. This is a Google Hangout, so um, it's all you have to do is send me your uh, contact information to cosmiclettuce@gmail.com. And as soon as I go live, I'll send you the link and you can pop into the panel down here and we can um, uh, uh, expand expand this experience a little bit more. Not just have me, talking the entire time, which I don't mind. I don't mind because I can talk astronomy all day and all night, no problem at all. But yeah, I definitely respect your time. As I said, I'm doing a little bit of experiment here to see if a shorter format maybe works a little bit better. Um, yeah, I don't know. This is just a casual, fun thing. So, I'm not going to sweat it too long or too much if it goes long or goes short or anything like that. Um, but yeah, cool. All right. Share this video also. Share it with your friends. Share it with those who you think might be interested in this kind of a con, this kind of a of a context, and yeah. All right. I'm gonna get out of here for now. Take care. Peace. Cheers. I will see you on the spin. Now, don't get dizzy. Don't get dizzy. I mean, we're spinning around awfully fast. So, hold on to your hats, keep your head down. It's a pretty smooth ride. It's a pretty smooth ride, so it's kind of hard to feel. Um, but yeah, take care, and I will see you on the spin a little more than 23 hours from now. All right. Take care, everybody. Peace and cheers. Bye.